On the 21st of April 2025, Pope Francis, the leader of the Catholic Church, died. The papacy entered a period of sede vacante. The throne of St. Peter was empty. Almost immediately afterward, more than 100 cardinals from all around the world, many of whom actually watched the movie Conclave to prepare, engaged in a papal conclave to decide a simple question: who is the next pope? On May 8th, white smoke flowed out of the Sistine Chapel, signifying the election of the new pope, Leo XIV, from Chicago. Moments later, the cardinals read this really long Latin sentence, and he walked out in the most Chicago way possible. Okay, this probably seems really confusing to the average viewer, but why is the conclave so intricate as it is today? How did the white smoke come to mean a pope and the black smoke come to mean no pope? Most importantly, and I know we AP Chem survivors, students, are asking right now, what are the chemical processes behind that smoke? I'm going to answer that today. Let's start with the history of the conclave and of the papacy. Early popes, like triple sig figs early, usually just appointed their own successors. But as the church grew, so did power struggles, from Roman emperors to kings, leading to chaotic papal elections. Through multiple reforms over the past 500 years, however, the papal conclave has become more and more systemized. Today's routine was set in 2007 by Pope Benedict XVI. So how does the papal conclave work? Well, the election of a new pope is dependent on cardinals, very high-level Catholic officials, who were under the age of 80. This year, there were 133 cardinals who met the criteria. They come from all continents except Antarctica, for hopefully obvious reasons. And once Francis died, they were flown in from all over the world into the Vatican City. There, they were fully isolated, no phones, no luxuries, and apparently food so bad it made the Waffle House look like a Michelin star institution. The cardinals voted in the Sistine Chapel, where they would engage in copious discussion and 4 rounds of voting a day. To cast a ballot, they would usually write the candidate's name on a piece of paper, read out a really long piece of Latin, and then put it into a pile. A 2/3 of a majority is needed to elect a pope. Now, the interesting part here is the treatment of these ballots once counting was finished. Starting in the 15th century, the Vatican began to burn ballots to show the public that there was no tampering with the process and that a vote was, in fact, actually going on. Soon, they started to add special chemicals to the smoke, chemicals that helped make the smoke black, which meant that there was an inconclusive vote, or white, habemus papam. There were definitely mistakes with the chemicals. At the 1987 conclave, for example, a confusing scene happened where the smoke was white at first, but then, confusingly, turned black. Starting in 2013, however, the Vatican has utilized a set chemical formula, which has been foolproof in the recent one papal election. The chemical products used by the Vatican are potassium perchlorate, KClO4, anthracene, a hydrocarbon with the chemical formula C14H10, and sulfur for black smoke. For white smoke, the Holy See uses potassium chlorate, lactose, and pine rosin, a type of extract which you might know from sports. The procedure is simple. They place the ballots in a pile in a furnace, throw in the respective chemicals, and light the concoction on fire. I recreated this experiment but was unable to use everything the Vatican used. I used KClO4 for both black and white smoke, and I used sugar instead of lactose. No significant difference, however, was observed. Here, I'll be explaining the Vatican's official chemical process, not mine. Here's a list of the quantities of materials I used for each experiment. Since there was no official measure, I tried to use small amounts of each, around 0.5 grams. As you will see, these were burned in a crucible with a piece of paper simulating the ballots. Let's start with the black smoke. The chemical reaction happening is a redox combustion reaction. What you are seeing on screen right now is a possible representation of this reaction, as there are no available sources online delineating the specific chemical formula. In this reaction, the Cl is reduced, which means that it will gain electrons. We can see the reduction as Cl has an oxidation number of +7 in the reactants and -1 in the products. Meanwhile, sulfur is oxidized, with its oxidation numbers changing from 0 in the reactants to +4 in the products. Okay, so how does this reaction actually create black smoke? To answer this question, we'll have to split the reaction up and analyze its individual parts. First, let's look at KClO4. KClO4 tends to decompose at high temperatures, which is when the concoction is set aflame with a lighter. It splits into KCl and 2O2. The oxygen will in turn be used to combust two things. First, the anthracene in a reaction that looks something like this. Just like any other reaction, it produces CO2 and H2O. Second, the oxygen from KClO4 will also react with the sulfur in a reaction that looks something like this. The sulfur is fairly insignificant in this experiment, since sulfur is very easy to combust. Its sole purpose is actually just to make sure that the burning continues. Now, in theory, this reaction would go to completion. However, it does not, and an incomplete combustion happens. See, from both the KClO4 and the atmosphere, there is much less oxygen than needed to complete a complete combustion of anthracene. As a result, many combustions actually look like this. C14H10 plus O2 only gives C and H2O. If the aforementioned reaction happens, then the gaseous carbon particles will travel into the airflow. Carbon is black, and since burning balance itself creates gray smoke, the carbon soot makes that smoke black. Therefore, no Pope, keep voting. White smoke revolves around a similar process. In this case, the Vatican utilizes potassium chlorate, lactose, and a special pine rosin. Now, the former two react in a combustion reaction as such. Note that, just like in KClO4, KClO3 decomposes once the temperature gets too high. The oxygen released fuels the combustion. This reaction is also redox, as chlorine is reduced. Its oxidation number changes from +5 in the reactants to -1 in the products. And carbon is oxidized. Its oxidation number changed from 0 in lactose to +4 in carbon dioxide. The key to the white smoke is water, which this reaction creates plenty of. Not only does the combustion of lactose itself make H2O, but pine resin is also copious in water. When heated, that water turns into gaseous form and travels up the airflow. The result? Lots of H2O in the smoke. And, just like a cloud, it's white. We have a Pope. So there you have it, the chemical processes of the smoke at the Sistine Chapel that decide the Pope for 1.3 billion faithful Catholics around the world. Let's hope that the Pope lives on for a long, long time and that we wouldn't need a conclave for a while. But if there is a conclave in the near future, at least make the food better, guys.